Our universe is jam-packed with galaxies you just shouldn't be able to see. But there they are. They are so old they defy the Dark Ages, and now James Webb has even found two of the oldest galaxies ever seen. To us, all of these discoveries need to be questioned, and we have to ask ourselves what they all mean, and which of our scientific approaches now have to be totally redefined. Have we been wrong, believing one thing too much almost a century? And are we maybe living in a universe with no beginning? This technology is progressing at a quite large, but as such, amount. In the summer of 2022, we launched James Webb, a revolutionary observatory with light sensitivity and range so great they're an order of magnitude better than we've ever seen from infrared light that we can now detect even the faintest light in the infrared with ease. As a result, we see much further into the universe than Hubble saw. James Webb's increased sensitivity is key because those objects were created very early on in the Big Bang. The difference in how much light Hubble and JWST can see is that they each see different parts of the visible range of light. JWST's focus is the infrared, while Hubble works largely in the visible ultraviolet light spectrum. With this technique, if you will, thanks to this technique, James Webb also sends through dust clouds his X-ray vision and see galaxies that were inaccessible to Hubble. Hubble already had made fantastic discoveries and had laid many of the foundations of what we know today about the early universe. That doesn't mean these boundaries cannot be pushed even further. James Webb is ready. This telescope may turn out to be the way that our science goes into a whole new direction. Sensational discoveries: uncover Z12 and uncover Z3. Now let's look at the first stroke of genius of the new telescope. Two unbelievably distant galaxies have been discovered in the Pandora galaxy cluster, so far apart that they can only be viewed through gravitational lensing, according to the James Webb Telescope. In truth, these two galaxies are a part of the galaxy cluster Abell 2744, located a bit less than 3.5 billion light-years from us. At this point, the gravity of the cluster is immense. It distorts space-time, the way the convex glass of a magnifying glass distorts space. It magnifies areas on the background, and you can see extremely far-away objects. However talented and well-equipped we are, our search was dependent on the ultra-deep NIR-SPEC and NURCAM systems provided by James Webb, which actually yielded clues to the epoch of Ryanization of space, revealing two of the most pickled old redshift galaxies ever seen. In cosmology, wavelength stretching from an ongoing expansion of the universe is called cosmological redshift. The more a galaxy is away, the more space the universe has expanded during the time it took light to get to us. Along its way, it shifts into the red color spectrum more and more. The more red we see, the more away the object is. These two galaxies, which humans simply couldn't see with our eyes, would never be seen by humans, or much else, without one of the cameras and spectrometers of James Webb hardly missing. A wavelength of light, no matter how faint. It was also pointed out that we are definitely dealing with two truly unusual galaxies, which it is difficult to quickly determine their age. Are they so old you shouldn't even find them? This newly discovered galaxy, Uncover Zeta 13, has a redshift of 13.79, and the other galaxy the same scientists found is called Uncover Z12. It has a redshift of 12.393, the fourth oldest and most distant galaxy. They existed when the universe was only 350 million years old. The two uncovered galaxies look quite unusual. The other galaxies with similarly high redshifts usually look dot-shaped, but the two galaxies uncovered have the strange structure of a peanut and a fluffy ball. Uncover Z12 is also unusually large, with a disk 6 times larger than any other galaxy at this epoch, and both galaxies are big too. Uncover Z12 is edge-on, 5 times bigger than any other such galaxy seen at this epoch. Incredible macies. Galaxy US astronomer Stephen Finkelstein discovered the next galaxy miracle. The science of how stars group together is not just the study of galaxy evolution. For Finkelstein, the story of the origin of man is the research into the history of the universe and the reconstruction of what happened in space-time. Answers to where and how life came from, and to how it spreads through space are somewhere in the story of how stars and planets are made. By using the James Webb Telescope, the Southeastern Arizona Carbon Star, SEAR, search for extremely old galaxies, astronomer at the Department of Astronomy at the University of Texas at Austin and principal investigator tracked down galaxies in the spectrum Z6, Z10. Previous to James Webb, these galaxies were nearly impossible to detect with the technology available to Hubble, but James Webb also provided Finkelstein and his team views completely new, and that translated into a sensational discovery. Finkelstein found the galaxy on his daughter Macy's birthday, and it's a demonstrable redshift of 11.4, meaning it only came into existence 390 million years after the Big Bang. In addition, Macy's galaxy is full of stars, and more stars are still being formed in this galaxy. It is also a real wonder for its age. But in Webb's new images, Finkelstein and his team found what looked like a veritable flood of complex galaxies. Some of them seem like pinwheels, others are blotchy specks or wafer-thin vortices. Right now, the researchers are hunting for around a dozen more galaxies that could themselves be far older. An initial measurement of some of them showed redshifts of up to 15Z and even more. GNZ11, how early days of the universe. Where GNZ11 is also a real relic from the past of the universe, with a distance of 13.4 billion light-years. The discovery of GNZ11, however, wasn't made by James Webb. Hubble found it in 2016 for once. That helps explain why a veteran of space telescopes proved he still has a lot up his sleeve when he announced this galaxy, surprising the scientific community. Furthermore, GNZ11 is so old is questioning previous cosmology. And unlike Macy's galaxy, which showed what was anticipated, it had already existed 400 million years after the Big Bang and still has an unexpectedly high star formation rate. All these galaxies speak one language. They are so highly organized, so full of old stars, so wonderfully structured, that they couldn't possibly have only grown up in 400 or 300 million years. If we trust our current cosmological models, they must be older. If so, though, that would mean they were older than even the Big Bang. No dark ages? The Big Bang is when our universe supposedly began some 13.8 billion years ago. Suddenly, space became an entire thing all at once. First, the universe was a highly compressed and hot plasma, the electrons and protons plunking around loosely. The moment the universe cooled enough to build the first stable hydrogen and helium atoms occurred roughly 380,000 years later, scientists calculated. The dark era ended and it slowly became light in the universe. Free protons and electrons were being acted on by photons that couldn't travel freely through the space. Light was able to spread freely the moment the first atoms were formed and made the universe transparent. Today, this first light is known as cosmic microwave background radiation. With telescopes, we can look back to this point in time, yet even James Webb isn't quite far enough to see it. What some people say is that the range of the telescope is about 13.5 billion years, and perhaps a little more, and we've got the cosmic microwave background. Now, James Webb has delivered us a full series of galaxies that were less than 350 million years old after the Big Bang. Getting a handle on these things takes billions of years, especially beautifully shaped and highly organized galaxies like the ones discovered by Finkelstein and his team. That would have meant that the discovered galaxies would have to exist long before the Dark Ages, which really isn't plausible. But how could galaxies have existed at that time, if atoms of hydrogen and helium were only now forming? The most Basic assumptions of conventional cosmological models are all called into question by these discoveries. Perhaps the dark ages of the universe were much shorter than we thought, or that the first stars and galaxies existed and grew more quickly earlier. Or maybe the universe, or what we call the universe, was actually more complex and more dynamic when it was younger, or the physical conditions were entirely different from what they are today. No non-stop expansion? We will have to say goodbye to many old concepts and our idea of the non-stop expansion of the universe. In the 1920s, Edwin Hubble was the first to observe that galaxies were receding from us. In fact, that led to an idea of Big Bang theory. That is the time when Georges Lemaitre proposed that the universe had expanded from one point. Hubble's idea later fused into cosmology, which still stands today, with Lemaitre's ideas. Many observations of our universe have cast doubt on the idea that the universe has been expanding uninterrupted for decades. This includes the arcane mystery of dark energy, the force that's supposed to make the universe expand even faster. But in 1998, scientists Saul Perlmutter, Brian Schmidt, and Adam Rees began raising questions about whether the rate of expansion of the universe changed over billions of years. Dozens of researchers since then have found similar evidence, though the expansion can sometimes be linear, then not. But some of those scientists have since concluded that the universe is not expanding at the same rate everywhere and by the same amount, and that could shed light on the mysteries of dark energy and dark matter. But we still do not know enough about dark energy and dark matter to make sense of the rest of the universe. According to Paul Steinhardt and Neil Turok's model, the universe undergoes a series of expansions and contractions instead of one enduring one. On the other hand, Fred Hoyle found evidence of existence of universe from all times and continues to exist in the constant state. The phenomena of apparent expansion were attributed to measurement and observational errors. The Big Bounce theory says that the expansion of the current universe is because of some previous collapsed universe, not a Big Bang. Subscribe to the channel now. There are many more great videos to come.